Hello and welcome back to this video for Common Lisp on I/O. In this video we're gonna start having a look at writing files, and we're gonna stick with text files for now. There's a lot more we can do, but I'm going to save working with binary files for another video. There's a particular project I'd maybe like to explain, if I can, to raise awareness of a type of industry in the computer science world that isn't especially popular or particularly well understood. However, I would need to make sure that I can talk about that and the sort of things that I want to work with are possible. So we will save working with binary files for another series. So we're just going to work with plain text files and get the understanding of files and streams. And we're going to continue again with the project that we've been working on. It's not really a full project anyway, it's just a wee playground here, really. So we've got our FIO, excuse the train. We've got our FIO project here, and we were just reading this file itself, but now we're actually going to start looking at reading and writing our own files. So, with nothing more ado, let's start drilling into that. And we're going to continue using this with open file macro, but we're going to have to introduce some new things here. So by default, the with open file macro assumes that you're in read mode. Python does exactly the same, but if we want to write a file out, we're just going to say in our home directory out.txt, we actually have to say direction output. Something else we need to do is if does not exist, we want to create the file. If exists, we probably just want to supersede everything in the file. So that probably looks like a lot of typing that you saw. As you saw here was just the beginning, and it auto-filled it for me. And it seems like you almost have to magically know what's there. I guess you do. But when you read it like English, it's not actually anywhere near as complicated as it looks. We're saying our direction is output, so we're outputting to a file. We're saying the file does not exist, we want to create it. If it does exist, we want to supersede it. So that's nowhere near as complicated as it actually looks when you read it out in English, and it's just knowing that we're wanting to specify direction, what to do if the file doesn't exist, and what to do if it does exist, and these create and supersede are keywords that exist. It's the same with output. I guess again you have to know that these exist by reading the documentation. So here you are, these are how we do this. Now let's start looking at this. The base level function we can use is simply called write, just like that, and it takes an object. In this case I'm just going to pass in a string, whoops, and it takes a stream, it takes :stream, and our output object here, our out object, is a stream. So files in Common Lisp, they are streams. So when you, excuse the other train, they're getting really busy lately, and I don't know why. These streams are how files are represented in Common Lisp when you open them. Lots of things are represented as streams in Common Lisp, but files are one of them. We will get into exactly what streams are and what other things might be represented by streams in another video. But we've got this, and I'm going to jump into the REPL on the right hand side. There we go. And I'm going to say open the terminal. You can see here that we don't have a file called out.txt. So let's evaluate this and jump down here we do now have a file called out.txt. And you can see here that we have just written hello world into the file. I could possibly have done this as well. %. So we've evaluated that again. And maybe in reality I need to do that. We'll see. Nope, made no difference whatsoever. Yep, nothing. So none of the sort of, well, I suppose this is a string. What I might want to do, why am I making it harder for myself? There we go. So yeah, I've got this hello world here. I should have just returned a string, so let's cat this file. Yeah, you can see that we have now printed hello world, and we've got a new line. So we have to just use the format macro there if we want to use our control characters to format a string. So this is how we would use the write method. I imagine, based on what I've learned, that this is possibly the low-level write function that what we're going to start using now is built on top of, because Common Lisp is very much about building low-level building blocks that you just build abstraction layers on top of. The next thing we could use is write car, and this takes a character, which we might have discussed before, are these things, these hash, backslash, and then a letter. So this and this are two different things. You know, characters are exactly what they are. They're a distinct data type in Common Lisp. So let's write that to our file, and then we'll cat it. So you can see here in the bottom, we've still got our original hello world, but we now have this individual a character. And we've got this wrapped around in quotes for some reason. Whatever. So we've got that a character there. This is how we'd write an individual character to a string. There's something else. There's like 3 other functions I want to get into. And they are starting with a write sequence, I think, because the other 2 are related. Write sequence takes some output, and it takes a stream. And you can see here that we've got our hello world from our string here, and our a and our hello world here. So let's try and wrap this in a format. Third train. Like, I apologize. I'm going to get no rest from these today. There's nothing more I can do about this. So we got hello world printed out. Ah, that's interesting. Yes. So, we can use format here with our strings, and that prints it without quotes. So we got this write with the format, and that quotes it for us, as we can see here. Then we just write a single a character and then a hello world. So, you know, we could also do this, I think. Write car hash new line. I think that's it. let's have a look. Let's see what we've got. Let's go to the bottom here. Yeah, there we go. So new line. Well, of course, because Common Lisp is case insensitive. So we've printed that. We've got our new line here. We've got our A. We've got our hello world. So I'm just gonna get rid of this in our string. There we go. That's okay. So this helps see what's going on here. We've got our string, which we don't need to format anymore, so we can just get rid of all of this. Yeah, there we go. Nice and easy to read here. We've got our characters, and we can write our sequence here. So the other two functions are very similar. Write string, it takes a string, and it takes a stream that we're writing it out to. So if we write that and we just cap the file here, that didn't do what I thought it would do. Another train. This is starting to annoy me. Of course, I've got this the right way round. Yeah, so write string ABC to the out. That should be fine. Ah, yeah, sorry, I didn't see it there. See, we've got this ABC here. I'm gonna put a write car so we can actually see see what's happening in our file. Yeah, there we go. That's easier to see. We've got these things here. So that's what write string does. However, if we want to change this, we can actually, to avoid exactly this problem that I've got here, we can actually say write line. And this does exactly the same as write string, but write line appends that new line character for us at the end of the output. So we can see here our write with our write car, the invisible new line, the A character, and again with writing a car of a new line, which is invisible here. Then we write sequence, which is hello world. We write string and an invisible new line, and then we write line DEF, which has an inferred end line character. Now there's more we can do here. Certainly our write sequence, our write string and write line methods actually have a little bit more to them than you might think. So let's say write line. This is a string, and we're going to output, we can say start 5 and 15, and if we write this to the file, although it said this is a string at the bottom there, we actually get the string starting from position 5 and ending at position 15, so we get a substring of it. So when you're writing lines, you can use these keyword arguments as well, which is pretty cool. They exist on write string and write sequence as well, so you can use these on those two functions. Now there's another thing that I'm going to try and get into. So I'm going to say with open file, I'm going to say out tilde slash out2.txt direction output if does not exist, create if exists supersede. And what we're going to try and do is we're going to try and use the write byte method. So this takes an integer, so I'm going to say 101, we'll say out. This might not work. Yeah, so to briefly cover why we're going to handle binary files differently, right, bear with me, excuse me. There we go. So that did work. And if I cat out 2, you can see that we got the E character down here. So 101 being the ASCII byte for E. Now, this is why this matters, is when you're dealing with bytes, you're not dealing with strings. So you have to set the element type of the stream to be an unsigned byte or some other value. There are others. So, you know, I could get rid of this. Not that you can see them, but there's loads on the right hand side. Unsigned integer. But I'm going to stick with byte for now. Evaluate it. And you can see in the bottom left that it says 101, and it's 7-bit encoding, and it gives you it in the various different number bases. And that is that's why we're going to leave writing binary data for another session, and why, you know, write byte, we're going to have to handle that differently. So let's just get rid of this for now and just have a look here. So there's nothing too crazy that we've added. Again, if you're ever wanting to have a look at what is available, remember that you can just work in the editor here and just start typing a space, and you'll see everything that's going on here. This is why I think that write is a low-level bit of code that all of these other functions take advantage of. But let's see what write car can do. You know, it takes a character and then, you know, an optional stream, which we pass in there. Write sequence. It takes a sequence, a stream, and it can take the keys for start and end, like we discussed. It defaults to starting from 0 and end will be nil. Write string, exactly the same. It takes a string, an optional stream, and then the start and end keyword arguments. Write line, exactly the same. A string, a stream, a start and an end. But write line has that inferred new line character at the end there. And that's it. That is all we really have to look into for writing text files. This is exactly what you could pass into the standard open function, but again, we're using that with open file macro. So we're making sure that file stream is closed when we're done with it. And you can see how simple it is to, you know, to just read a file in, although you should of course have, if it doesn't exist when you're reading a file in. We talked about this in error handling, you know, in a previous video. We've got an error here. This could very easily have been handled with if does not exist. We could provide a value, or we could create a blank text file. You know, if does not exist, then we pass in nil. So that's another thing you could do, but you know, you've got a value, or you've got these keyword parameters that do something specific. Now there's a difference between supersede and override. So if we have a look here, if it exists, let's see. Oh, I know actually. If exists, it's not telling me. That's a shame. So I'm going to say supersede. So my understanding is Supersede will like truncate the file and write everything from the beginning, whereas override will move the... Do you remember last week we were talking about how program was stored on tape? And for the younger ones of us in the audience that have never experienced this, if you recorded something on a tape, let's say you recorded a song that was 6 minutes long, and you then wanted to record over it, and you rewound the tape to the beginning and you recorded a song that was 3 minutes long, you'd hear the 3 minutes of the new song, but it would just start playing the remaining 3 minutes of the first song, because although you had recorded over it, the tape did continue. So this is what this override and supersede, the difference between this is because when you've got this stream open, you've got like a pointer. It is a pointer at the end of the day. If you don't know what that is, well, I'm not going to get into that, but it's something you use a lot in C. To be fair, you use it a lot in almost every language, you just don't know it. Anyway, sorry, I'm getting off topic. You've got this like address, and what override in Common Lisp does, I think, is it just moves you straight to the beginning of the file and allows you to start writing, and whatever was in the file stays there. So you could write, 6 bytes of data, and if then you override and write 3 bytes of data, you've got these 3 new bytes of data, but the remaining 3 bytes from the first time you wrote the file stay there. Supersede, however, will erase everything and put you at the beginning of the file. That is the way I believe it works, and that is the difference between the two files. The two keyword parameters here. It's a subtle but very important distinction, and if you get it mixed up and are doing particularly sensitive stuff, you might have a file that is the amalgamation of a couple of things. And you know what? We are going to find out. Enough talking about it. Let's see what it does. So we'll just say out, and that's yet another train. I don't even like trains, well, they're useful to travel on, but I don't live here because the trains are lived here because, well, I want a place to live. Whoops, I've put the closing parentheses in the wrong place because I got distracted. Right, so we're going to say write hello world. I'm going to say to the stream out, and then we're going to copy this if it exists. I'm going to say hi world here. I'm going to copy these 5 lines. Over right. I think that's the one I want. So let's evaluate this first, and we're going to cat out 3. So we've got hello world. So we're going to evaluate this, and we're going to cat out 3. Then we got hi world. So we're going to evaluate this one for output 4. I'm going to cat that. We got hello world. Now we're going to evaluate this one. I'm going to cat out 4. So yes, this is exactly the difference. You can see here that we got hi world written as a string, but we have the D exclamation mark and closing quote from hello world, and there's 3 extra characters left over in the text file here because we overwrote and we didn't supersede. So that is the subtle but important distinction there. So I think that's enough to be getting on with. I think I've explained and taken up enough of your time about outputting text files. Next video, I'm going to start a new series on some functional stuff, which is going to be fun. Pun intended. It wasn't intended, but I'm going to claim it because that's something I would say. So fun with functional programming is the next sort of series of videos we're going to start. So yeah, I hope you are all doing well. Hope that was fun and you've learnt something. I will see you in the next video.